In this lecture, we will study volts ampere characteristics of PN junction diode. X-axis represents voltage across the diode and Y-axis represents current through the diode. In this lecture, we will draw volts ampere characteristics for both forward and reverse bias condition. And if you remember the forward bias condition, we connect positive terminal of the battery to the P side and negative terminal of the battery to the N side. So first I will make the circuit. This is the symbol of diode. This is P side, this is N side, and we will connect P side to the positive potential and we will connect N side to the negative potential, and voltage across the diode is equal to VD and current through the diode is equal to ID. Now from diode current relation, ID is equal to IS, where IS is reverse saturation current. In bracket we have E raised to power VD divided by eta VT. This is eta ideality factor minus 1. This is the equation of diode current, and if we consider the condition in which VD is equal to 0, it means voltage across the diode is equal to 0. We can also call it no applied bias. This is the no bias condition, and if you see this plot, you will find this is VD equals to 0 and we have to find the diode current at this point. I will use this equation, ID equals to IS e raised to power 0, because VD is equal to 0, so we have e raised to power 0 minus 1. Now e raised to power 0 is 1, so we have ID equals to IS 1 minus 1. 1 minus 1 is equal to 0, so ID is equal to 0. So this is what we have when the voltage across the diode is equal to 0. The diode current is also equal to 0, and thus we have diode current equal to 0 when VD is equal to 0. Now we will increase VD in positive direction, not in negative direction, and we can say that diode is forward biased, and on increasing VD, width of depletion layer decreases on increasing VD, and also barrier potential decreases, but still diode current is equal to 0 because the barrier potential is strong enough to prevent electrons crossing the junction. But if you go on increasing the VD, if you go on increasing the forward bias potential, VB reduces further, and there is small current through the diode because some electrons will cross the junction and there will be current through the diode. So there is small current through the diode, and when VD is equal to VB, it means the forward bias potential is equal to the barrier potential. There is flood of electrons crossing the junction and we have rapid increase in current, as you can see here. This is the plot of germanium and this is the plot for silicon, and in case of germanium, barrier potential is 0.3 volts, and in case of silicon, barrier potential is 0.7 volts. So if we consider the case of germanium, if VD is equal to 0.3 volts, it means VD is equal to barrier potential. There is flood of electrons crossing the junction and current will increase rapidly, and if you increase the VD further, the current will increase exponentially. So there is generous flow of current through the diode if VD is greater than or equal to barrier potential. And in case of silicon, if VD is greater than 0.7 volts or even equal to 0.7 volts, we have generous flow of current through the diode. So this is all for VI characteristics in case of forward bias condition. Now we will move to reverse bias condition, and in case of reverse bias condition, positive terminal of battery is connected to the N side and negative terminal of the battery is connected to the P side. So first I will make the circuit. This is the symbol of diode. We will connect P side to the negative potential and we will connect N side to the positive potential, and the voltage across the diode is VD, and we have to find current through the diode. So we will use this equation, id is equal to is in bracket e raised to power vd eta vt minus 1. I will use this, and in this case we have vd negative, or we can say that vd is less than 0. So this is what we have in case of reverse bias condition. This is for reverse bias condition, and if we make vd negative, then let's see what we have. id equal to is in bracket we have e raised to power vd eta vt minus 1, and now this vd is negative, so e raised to power vd eta vt is less than 1, and this is when vd is negative. So we can neglect this term, and we will have id equals to is minus 1, or we can write id is equal to minus is. So the direction of current in case of reverse bias condition is opposite to this direction, and we have only one current in case of reverse bias condition, and that is the reverse